Okay, 4.7. Recall that if something has an inverse, it must pass the horizontal line test. So if we look at the sine wave, remember this is a typical sine wave, does it pass the horizontal line test? The answer is no. However, if we restrict the domain from negative pi over 2 to positive pi over 2, so that our graph looks something like this, it now does. So on the interval, negative pi over 2 to pi over 2, there is an inverse sine function. We use the word arcsine or sine to the negative 1. They both mean exactly the same thing. So if you see both notations, know that they are interchangeable. The domain is negative 1 to positive 1 because it's an inverse. Remember, we're looking at our y values, positive 1 to negative 1. And then the range are the x values, so therefore the y values. Keep in mind, this is the inverse domain and range. So that means the x's are the y's, negative 1 to 1, are the x's. When we look at this, it is in quadrant 1 and in quadrant 4. If I were to look at a picture of my XY axis, this part of my circle is quadrant 1, but then we're looking at this backside, and this backside would be quadrant 4. So quadrant 1 and quadrant 4. As we look at cosine, just do kind of a quick sketch here. Here we have a cosine. If I'm looking at the inverses from negative 1 to 1, I'm looking at 0 to pi for the x's, which are the y's on the arcsine, and negative 1 to y on is the domain. Therefore, that's quadrant 1 and quadrant 2. It's important to know that the inverse lives in certain quadrants. Inverse of cosine is in quadrant 1 and 2. Inverse of sine is quadrant 1 and quadrant 4. And when I look at tangent, knowing its boundaries are pi over 2 and negative pi over 2, therefore its inverses live in quadrant 1 and quadrant 4, just like the inverse of sine does. All right. When we're asked for arcsine of negative 1/2, the question you're really going to ask yourself is, what angle has the sine or cosine or tangent or whatever function we're looking at here of, in this case, negative 1/2. So what we're looking for is what angle has a value of negative 1/2. Well, we should know negative 1/2 sine is either quadrant 4 or quadrant 1. And sine of 1/2 is the reference angle of 30 degrees. So if I'm negative, I'm in quadrant 4. And if I'm in quadrant 4 at 30 degrees, quadrant 4, 30 degrees, that's negative 30 degrees, or negative pi over 6. I do not answer Do not answer 330 degrees. Because of the rule that we just said on the first page. The inverse is quadrant 1 or quadrant 4. Right? 330 degrees is not in quadrant 1, and 330 degrees is not in quadrant 4. I have to answer within my quadrants. So I'm answering negative 30 degrees or negative pi over 6. Okay, so whose angle, what angle, gives me root 3 over 2? Well, positive, so that's either quadrant 1 or quadrant 2. That references 60 degrees. Well, the one that I can use for arc sine is quadrant 1. Therefore, 60 degrees or pi over 3. Arc cosine, so what angle on cosine gives me a negative 1? Well, cosine negative is either quadrant 2 or quadrant 3. Negative 1 references 180 degrees. So quadrant 2, according to my rules, cosine can either only be quadrant 1 or quadrant 2. So I have to reject quadrant 3. And it references 180 degrees or pi. Tangent. Tangent of 0. Well, tangent is quadrant 1 or quadrant 4. According to my rules, I can only be in quadrant 1 or quadrant 4. 0 is only 0. So whether it's 0 degrees or 0 radians, it's the same thing. Arctangent, negative 1. Well, tangent itself is negative in quadrant 3 or quadrant 4. But the inverse can only be quadrant 1 or quadrant 4. So it must be quadrant 4. Negative 1 references 45 degrees, which is negative 45 degrees or negative pi over 4. Use a calculator to approximate these values. So this is just second tangent. Second tangent, negative 8.45. We get negative 1.453. Make sure you're in the right mode. You have to be in radian mode there. And then second sine, so 0.2447, you should get 0.2472. When you're doing composites, a function of a function, in this case, if they're the same, here, sine, arcsine, sine, cosine, keep in mind, that's like saying sine times the inverse of sine. And we should know that inverses always cancel each other out. So that leaves x and it leaves y. It leaves x, it leaves y. It leaves x and it leaves y. They're all the same. Because a function and its inverse cancel each other out. Alright, so these three questions down here I'm going to do on the back side because there's just more room there. So we're going to start with tangent and arctangent of negative 5. Okay, we get to eliminate that. Tangents, arctangents, all goes away. So we have -5. One thing we need to make sure of is -5 is in the domain of all reals. Alright, the next one. Arcsine and sine of 5 pi over 3. I need to be careful of this. 5 pi over 3 is in quadrant 4. I need to have its reference because 5 pi over 3 is not actually the quadrant 1, quadrant 4. So I have to find its reference, pi over 3, or 60 degrees. Therefore, its value is √3 over 2. This is of an angle here, and I need to get its value. So now I have arc sine of -√3 over 2 because I'm in quadrant 4. Quadrant 4 sine is negative. So what angle gives me -√3 over 2? Make sure it's within the domain. And we get -pi over 3. Alright. Tangent arc cosine of 2/3. Alright, I don't know 2/3. 2/3 is not one of my values, it's not an angle, it's not anything. So when you come across something like this, and also tangent and cosine don't match up, so I have a real problem here. I need to make sure that I have the same in order to be able to cancel them. So this process is always going to be the same. We're going to let u equal arc cosine of 2/3. So now I have tangent scratch that, sorry. Let u equal arc cosine of 2/3. Therefore, u is equal to this inverse. It's just a new way of writing it. And again, changing the writing of it says, so what angle gives me 2/3? Well, if I know my numbers and I know my function, I know my triangle. Here's u, cosine is 2/3. This missing side, by Pythagorean theorem, is √5. Now I have tangent of u, and because of my picture, tangent of u is √5 over 2. That's how I'm going to solve those. So we're going to try that again. Cosine of arc sine -3/5. Let u equal arc sine of -3/5. So just rewriting it, sine -1 is -3/5. So the angle u gives me sine -3/5. All this is just rewriting it. If I know I'm looking for an inverse, I know I'm looking for the angle of that sine. I can make a picture, and this is going to be in quadrant 4 because it's negative and we only have an option of quadrant 1 and quadrant 4. Opposite over hypotenuse. Therefore, the missing side by Pythagorean theorem is 4. So now if I want cosine of u, adjacent over hypotenuse, and we have our solution. You'll definitely be seeing these again, but that's going to be 4.7.